but let's state it. So if you happen to have some number, there it's called star, and you know that number star is bigger than some number c. You can translate that to a system of inequalities that don't have any absolute values in it. And maybe you can even draw a picture to remember. So let's think about the number line. Let's suppose you want to think about numbers that are bigger than 3 in absolute value. So what does that mean? Well, if there's 0 and there's 3, well, if x happens to be positive, then the absolute value of x is just x. So it just becomes x is bigger than 3. So if x happens to be positive, it's those numbers. If x happens to be negative, well, it becomes negative x bigger than 3, right? So let's think about what this becomes. You could multiply both sides of this inequality by the negative, get rid of the negative. Since we have strict inequalities, we exclude the endpoints. So you can translate a number as bigger than c in absolute value to that number being bigger than that number c, or that number being less than negative c. You feel pretty okay? And, well, that's what happens when absolute value is bigger than that constant. Oh, I thought there was more color. Oh, excellent. Wonderful. Thank you. If you want absolute value of x strictly less than 3, I guess that should be basically the rest of the picture, except for the endpoint. So, on the other hand, if you want to think about absolute value of x being less than some constant, the inequality becomes that when you erase the absolute values. People feel okay right now? So, let's use those ideas to solve a slightly complicated inequality that involves some absolute values. Let's try to solve this inequality. Absolute value of x minus 2. Absolute value of the absolute value of x minus 2 minus 3. Closed absolute value is less than 2. So, I think that's too complicated to do all in one fell swoop. So I'll advocate this. Let's get rid of one set of absolute values at a time. So here I see absolute value of some stuff less than 2. So absolute value of stuff less than 2. According to these rules, what should that become? Yeah. Negative 2 is less than stuff. And I guess that stuff has to be less than 2. No, I should not write the word stuff because something goes in that line. All right. So that means this inequality itself will become negative 2 is less than the absolute value of x minus 2 minus 3 is bigger than negative 2. And the absolute value of x minus 2 minus 3 is less than 2. So we've taken the inequality we started with and replaced it with two different inequalities. Both of those inequalities look simpler than the one we had before. Hope so. Let's try to solve each of them. So let's take these two inequalities and try to simplify them a little bit. In looking at those, what would you want to do to simplify those inequalities? 3 on both sides. Just get rid of that minus 3. So let's do that. So add 3 to both sides. 1 is less than absolute value of x minus 2. And absolute value of x minus 2, add 3 to both sides, is less than 5. Oh, neat. Are those both inequalities that we can use this rule to say something about? Yeah, let's use that. This one first. 1 is less than absolute value of x minus 2. What does that become? Well, whenever you see absolute value is bigger than a number, that's going to say that either the number itself is big, or that number is big and negative. So, in this inequality, 1 is less than the absolute value of x minus 2 is going to translate to either just 1 is less than x minus 2. Oh, yeah, thank you. Is the zoom also big enough? Should I zoom in further? Is it visible okay in the back? Okay. So it'll either become 1 less than x minus 2, or how about this? This one says that the absolute value of x minus 2 is less than 5. So what does that become when you get rid of absolute value? Yeah. And one more thing is we did. Yeah, which this time I'll write as a single thing because there's no more absolute values to worry about. So I'll use the more condensed notation. All right, so now I see like 3 inequalities put together with some logical statements, ands and ors. Each of those look like reasonably simple inequalities to just get x on its own. Yeah, so let's put them together. What does this become if 1 is less than x minus 2? What can you tell me about x? Yeah.
It's greater than 3.
Greater than 3. If negative 1 is greater than x minus 2, what can you tell me about x? Look at this. Add 2 to both sides, you'll get plus 1 is bigger than x. Feel okay so far? And finally, add 2 to everything in sight here. I believe you will get, let's use green. Add 2 to both sides. Negative 3 less than x is less than, add 2 to both sides, 7. Folks feeling all right? So we have this string of logical statements. Let's try to translate it to something involving intervals. Now let's do that by drawing each of these one at a time and figure out where this thing is true. So maybe I'll get myself more lines. Draw these on individually. All right, so I see 3 is less than x. So let's just draw that. If there's 3, open circle, 3 is less than x. If x is less than 1, well, there's 1. There's x is less than 1. And these two, well, only one of them needs to be true. So, as long as you're in either blue or brown, you're happy on that. Let's also draw this. Negative 3 is less than x is less than 7. I'm not going to worry about drawing it to scale. Negative 3 is less than x is less than 7. So you also need to live in that green interval. So let's just try to highlight what numbers actually satisfy all of these inequalities. So if you take a number out here to the left of negative 3, that is not included in your solution, because it's not in the green bin. Once you get to 3, though, then you're in green and blue. So that means that those values solve the inequality. Between 1 and 3, you're not in blue or brown. Once you're at 3, you're good, and you're good all the way on up to 7. Oh, neat. Does that just look like some intervals now? How would you write that in interval notation? Yeah.
Parentheses negative 3, comma 1, parentheses.
Negative 3 to 1 together with 3 to 7. And we haven't used the particular notation I'm about to use, but it's convenient to have a language that says you want things that are in either of those two sets. And I'll use the union symbol for that. Not important if you use that notation. I would be happy if you went negative 3, 1 together with 3 to 7. All right. People feel pretty happy about that example? And in particular, no one asked me questions about that homework problem that was assigned today. But hopefully people are feeling better about that homework problem now. All right. Cool. So, in those 15 minutes, I've covered the last of the things. Wait, questions before I do move on. Yeah. Oh, no, you're happy. Okay. Maybe I'll do one more thing. Let's check this graphically. You can look at a picture and try to see if this answer looks reasonable. So I'll advocate for doing that, and let's do it right now. So how many people pack graphing calculators when they come to this class? All right. So I'll advocate you to graph along with, and I'll pause to see if people are doing it. So I'll pull up the graphing tool that I like to use. You won't be allowed to use it on things like exams, but on homework, in truth, like, graphing calculators are a silly device. They're a technology that hasn't changed in any way since the 90s. The price has stayed fixed the whole time, and at no point will you use a graphing calculator outside of taking a class. If you're going to do something in the real world, you're going to use a tool that's more powerful than a graphing calculator. Anyway, that's my rant about graphing calculators. If you don't have one, I'm advocating don't bother purchasing one. If you have one, great, play along with it. So, let's graph a thing. I'm going to graph this original function. Absolute value of x minus 2 minus 3. So there's, if you like, a computer output of each x value and the corresponding y value. And I want to know, when is this bigger than 2? Yeah, that'll do. So I want to know what inputs, what x values result in this output value, the y value, being less than 2. And let's just see if this agrees with what we found. So it looks like these y values are too big. So these x values should not be in the solution. It looks like it changes to be true at -3, which I think is consistent with the solution we found. Then it keeps being true for a while. Desmos is going to try to give us some helpful points, some of which we don't care about. It looks like it stops being true at x equals 1, which again agrees with what we found. That's encouraging. It starts being true again at 3, stops being true at 7. So I think this picture agrees with the answer we got. Nice. So I'm absolutely an advocate of once you finish a math problem, especially if you don't have a time crunch, there's no reason to have a wrong answer, because a lot of times you can do things like this to check if your answer is reasonable. How'd that feel? That feel okay? Nice. So, the thing that I want to introduce now is more things about graphing. I guess in some sense we just did. So let's start to build up the actual tools of this. So what is it that we just drew? We drew a picture in the xy plane, in the Cartesian coordinate plane. So let's just say explicitly some things about Cartesian coordinates. So what are Cartesian coordinates? So Cartesian coordinates, the idea is anything that you can express with a pair of numbers, you can draw in a plane. And here's how you do it. So start by drawing some horizontal number line and indicate its origin. That's a very faint color. Draw a vertical number line so that they share an origin. This point, where they meet, I will call that point 0, 0. Next, if you want to find a point, say 5, 3, what do? Well, this coordinate 5 tells you how far to travel horizontally, to the right, 5, and up 3. That point is called 5, 3. And of course you already know this, but it's worth saying. If you're given a negative, you just go in the opposite direction. Negative 4, 2. Is there. It's useful to have some language to talk about quadrants, to talk about particular regions of the plane, and we'll just give them names. The names will be arbitrary. The set of points xy where both the x and y values are positive, that'll be called quadrant 1. And, well, what does that correspond to? That corresponds to x values that are positive and y values that are positive. That's quadrant. And from there, we'll just label counterclockwise. Quadrant 2, quadrant 3, quadrant 4. So with that picture in mind, let's just solidify some ideas. So quadrant 2, what can you tell me about x and y values in quadrant 2? Looks like the x values are positive or negative. Negative, because they're to the left of the origin. What can you tell me about the y values? Positive. You go up to get to them. Quadrant 3? Both negative. Quadrant 4. Groovy. All right. So that's just a convention to keep in mind. We'll often label things according to what quadrant they wind up in, and it helps with being able to navigate in the plane, having those words to talk about. And there's going to be kind of a potpourri of topics that I'll hit now. Let's talk about measuring distances. If you have 2 points in the plane, it's really useful to be able to do geometry. And to do that, you want to measure distances. So let's figure out, how could you measure the distance from the point -1, 1 to the point 2, 3? And maybe this triangle is supposed to help. I'll label this point as well. Or maybe I'll ask you to. Looking at that picture, what does it look like the x-coordinate of that point is, if that's a right triangle? 2. And what's its y-coordinate? 1. Nice. Should have the same x value there, same y value as there. Let's see what we can read off on that triangle. What's the length of the base of that triangle? 30. Why 30?
The x value of the bottom one.
Yeah, we look at the distance between the x values. So I guess that's an absolute value of a difference. Absolute value, so you don't have to worry if you subtract it in the wrong order. What's the height of this triangle? Cool. Is there some rule that says if you have a right triangle and you know the base and the height, then you know the distance of the hypotenuse? There's the Pythagorean formula, which is a thing which I definitely haven't mentioned yet, so maybe I'll mention it. A squared plus b squared is equal to c squared. Whenever you see a right triangle, and you know those two lengths, you know the length of the hypotenuse via the fact that c squared equals a squared plus b squared. So if you want the length of this hypotenuse, let's call it c. Right? The length of that straight line will be the distance between the 2 points. Well, let's try to compute it. Or maybe I should just stall for a minute. Tell me, what is that distance? Yeah.
Be what square root of 13.
I don't know, I didn't do the calculation. Does that agree with everyone else? Cool. Should I go through it? In this case, it's a trick question. I'm going to. Sometimes I'll care about your answer, but this time I don't. So let's use the Pythagorean formula to do this. So apparently, c squared should be the same thing as a squared plus b squared. And let's see what we can do with that. What's 3 squared? 9. 2 squared? 9 plus 4 is 13. So it looks like c squared is 13. I would like to know just what c is. So how do you get rid of that square? Square root. And maybe I'll mention the following subtlety. In general, when you get rid of a square by square rooting, you need to worry about whether the result is positive or negative. Right? If you take a negative number and square root, it becomes positive. So when you undo a square, you forget whether the input's positive or negative. But why can't it be negative this time? Distance can't be negative. Yeah, distance can't be negative. There's a notion that sometimes gets talked about called signed distance, which can be negative, but we're not in that situation. Distance is positive. So it looks like square root of 13 is that distance. Yeah?
Wait, square root of negative, wouldn't that be the imaginary number?
Not the square root of a negative square root. So the difference being the negative outside the square root. Right? Yeah. Cool. We will mention the ideas of negatives inside of the square root and what imaginary numbers mean in a while. Radical. So, was there anything special about these points that made this procedural walk? No. In general, you could do this for any pair of points. And in fact, you could just get a formula. It looks like you'll always take the square of a base, the square of a height, and then take a square root. In general, following distance formula. If you have any points, x1, y1 in the plane, and x2, y2 in the plane, so maybe a picture is in order. Maybe there's some x1, y1, x2, y2. You want to measure the distance between them. that distance formula says that this distance from x1, y2 to x2, y2 is given by the square root of the difference between the x coordinates squared plus the distance between the y coordinates squared, and then you take a square root. So I've written x1 minus x2 and y1 minus y2. Do you think it actually makes a difference what order you put those in? Oh, let's do a quick, yeah.
I was just going to say no, because either way you're going to square it.
Either way you're going to square it. If you like the difference of a negative will go away. How many people think they would benefit by doing an explicit computation to see if it makes a difference? Let's do a computation and see if it makes a difference. Let's use the exact same point as we just used. Let's compute the distance from previous page, -1, 1 to 2, 3. So let's do that the two different ways. So I'll use x1 minus x2 and y1 minus y2, and then we'll do the same in the opposite order. Square root of x1 minus x2, -1 minus 2 squared, plus y1 minus y2, 1 minus 3 squared. And let's see what we get. -1 minus 2 is -3. Right? Take a negative and you subtract from it, it becomes more negative. Square root of parentheses -3 squared plus 1 minus 3, -2 squared. So notice, because we subtracted in the order that was the smaller things coming first, we wound up with negatives inside of the parentheses. Do those negatives actually matter now? No. Because of exactly what you said. We're squaring them anyway, so the negatives will go away. Nice. And now let's just not write anything. Let's just imagine what would have happened if they were in the opposite order. If instead this were 2 minus -1, subtracting the negative is the same as adding. That would be 2 plus 1. So there would be a 3 inside of those parentheses. Oh, neat. You would still get the 9. If it were 3 minus 1 there would be a 2 inside of the parentheses. 2 squared, also a 4. So the order doesn't matter in this case. Sometimes it will. Nice. People feel pretty good? All right. So I have the following application-based example that I would like everyone to engage in. Let's describe it as slightly bullshit. Here's a thing that I would like to know. Pick a wall of this room. I would like to know the diagonal distance from corner to corner on that wall. And here is the tool that I have for you to accomplish this. I have measuring tapes and tape measures that are too sharp to accomplish the goal. So, here's what I'd like you to do. Get up, meet those around you. Maybe I'll order things this way. You walk with the next row behind you. That's a set of wall. Oops. I'll give you 5 the extra sharp tape. There, and you 3. You 4, and no, I have 2 of these in the front. I'll put those behind you. And this back row. All right. So I'm giving you very little guidance here. Coordinate with each other, pick a strategy, pick a wall, and then get the wall. Sure.
Oh, wow.
Hold on, I think that's also the other side. Yeah. Does not. Feet.
Pick a unit. And I know it sounds fun, but pick any one. Ideally, we'll do all of them. And I'll just try to not be in the way.
What? They have like a lot longer.
But it's probably still not long. Yep. So.
My recommendation. Only barely long
That's as far as you can go. Is there a midpoint in this room that we can do? I don't double it.
How many inches is it? Oh, there's
I'm estimating about 12 feet down the middle.
what did they get?
That brings me 87.
This one's 287.
287 inches?
We just did that wall in inches. So I don't know. Are we going to convert that to feet?
You could have.
Okay. It's like, wait a minute.
Maybe we should go to the
I don't think he wants height. Diagonal corner.
I want the diagonal.
So
Yeah, but you just use it there.
yeah, my question is how we're gonna get it to the ceiling.
Oh, no. So I won't give you freedom, but I don't want you standing on a wheelie chair.
Just drag the desk over.
Yeah, that seems unsafe. I think that would be non-compliant.
This man's like, wow. So each brick is 8 inches. So 2, 4, 6, 8.
16, and then whatever this bottom one is, that's just 16.
So they're each what, 5 inches?
Can we borrow your guys'?
Yeah. We're helping. Sort of.
It's bad.
Wait, you said that's 17 feet?
Yeah.
17 bricks.
Okay.
Why, is that some wrong?
17 feet? I'm just like, I have 6 17
It's
feet.
just not either.
So 136.
Okay, so we got 136 and 287. So what, 136?
Yeah.
136 and 287. I got 26 and a half feet for the diagonal.
Okay. It's 317.59 inches, roughly. Do we want to convert it? That's it.
Also, I'm just reading the Red Bull.
Oh, yeah.
And it's like, the Red Bull yellow addition, the taste of tropical fruits, artificially flavored drinks, Red Bull is appreciated worldwide by top athletes, racing professionals, college students, and travelers on
So, I think people are getting close to having another ball. So I'll pause for, I'll wait for another ball. So,
Yeah, well, actually,
yeah. All right, let's hear some things. What is the length of a wall?
diagonal.
Diagonal. All right, well, diagonal, just, yeah, across that.
that wall is
317.59 inches.
So I'm going to round to the nearest inch, and my justification is as follows. Are you confident of the number you gave me that it's true within 1/100th of an inch? Are you confident that it's true within an inch?
Yeah.
Oh, okay. That's good. So, there's one. Did anyone else measure a foot wall? I think you were the only groups I saw out there. Any other wall? Or any other measurement? I guess maybe I didn't get enough attention with people. Yeah.
If it wasn't said, for the half inch, this one, 291 inches, 208.
That was for the back wall, you said? All right. Now, ostensibly, the back and front wall should be the same diagonal length. This is a cubicle room, I think. So, the tools I gave you weren't great for the job. We'll talk about the techniques people use. What about the left or right? Well, I guess that's my left, so. Anyone measure that wall? That one? I mean, I saw people measuring it, right? I thought I did. No? Okay. Let's just see if everyone's numbers agree then. Anyone get other numbers for either the front or back wall? Pretty sure I should have like more than two numbers. I don't trust any of the numbers really, so like, don't worry if your number disagrees. I assume that they're all. Let's hear others. Yeah.
On the back wall, I got 26.5 feet, which is 318 inches.
Oh, hey, that agrees. All right. Maybe I have more confidence in the 318 number now. Yeah, I guess I'm trusting that you. No, that seems like reasonable for multiply that number by 12. Yeah. Okay. Cool. People get things in that ballpark? Yeah. So let's talk to strategies. So, what strategies people use? Tell me about them. Yeah.
We measured each individual like cinder block and whatnot, and just multiply by quantity.
Yeah.
For the initial base.
Yeah, so measure the length of one cinder block and multiply out. I guess the only downside there is if you measure one cinder block, you have some error. When you how many cinder blocks were there?
I think it was 15 across, but then you had to individually measure the different size ones.
Oh, there are some that are differently sized together.
Some of them are just like more cubish.
Yep, okay.
We had to add those on top.
Yeah, I see that. Yeah. And I guess when you add a bunch of things together, each one of them you are probably confident of within a half or a quarter of an inch. But then when you add them all up, those errors can stack. Which is a thing to worry about, especially if you're doing something you care about. How about the vertical line? How do people measure that? Yeah.
Same way.
Same way? Measure one cinder block and multiply? Did you account for the strip on the bottom? Strip on the bottom? Yeah, I mean, somehow, this isn't a class about how to measure things. So, I'm pretty happy. All right, so we got some practice with the idea of measuring diagonal distance using the Pythagorean formula. There's the goal. I'm going to talk through a computation which has an error in it, and it's written down right here. Let's see if we can spot the error. So the following is incorrect. Here's a computation of the distance between the point -35 and 32. So step one, using the Pythagorean, the distance formula, take the difference between the x coordinates and square it. Take the difference between the y coordinates, square it, and add them together. Does that apply the formula correctly? No errors yet. It looks like evaluate inside of the parentheses. -3 minus 3 is -6. 5 minus 2 is 3. Is that correct? So far, so good. Squaring. -6 squared is 46, I hope. 3 squared is 9, I hope. All right. Distribute the square root over the square. Anything wrong there? Yeah, that's wrong. You can't distribute the square root over a square. Square roots don't add nicely. So this step is incorrect. So caution sign, square root does not distribute over addition. If you take the square root of a sum, you can't apply the square root to each piece. The square root isn't a linear function. Linear functions are the ones that will behave roughly like that. So, that's a caution that I want to make explicitly, because do you think that that's probably an error that's really easy to make if you're just going through on light autopilot, maybe you're a little tired?
Yes.
Yeah. This is why it's worth doing some things to double check. If you double check your answer, you see that it's incorrect. Maybe you're using the web work and it just tells you that you're incorrect. Look through your work, see if you did that. That seems like a really easy error to make. So there's one formula worth knowing, the distance between 2 points. Let's talk about the midpoint. So first I guess the midpoint between two numbers is worth writing down. So the midpoint between two numbers, A and B, is also just another code word for the thing you already know called the average. Take the numbers, add them up, divide by 2. And let's just see if that works out reasonably. Let's find the midpoint between 4 and 10. So, I don't know. Maybe I'll just pause for a moment. Apply that formula. Tell me what that midpoint is. Right here are 7. People agree? Should I go through it? All right. Let's see if it visually looks right. So there's 4, 5, 6, 7, 8, 9, 10. Not on to any sort of perfect scale, but 5, 6, 7. That look like it's about halfway between 4 and 10?
Yes.
Cool. I think I believe it. You can compute the midpoint between 2 points in the plane by just computing the midpoint between the x-coordinate and the midpoint between the y-coordinate. The midpoint from x1, y1 to x2, y2 is given by, and I'll write a few lines here, the midpoint between the x-coordinates, comma, the midpoint between the y-coordinates. And if you want to expand that out further, that is x1 plus x2 over 2, comma, y1 plus y2 over 2. That idea seems sensible? If you want the point exactly halfway between two given points, just take halfway between the x-coordinates and halfway between the y's. And let's visually see if it seems sensible. Let's find the midpoint between these 2 points, and let's see if it works out okay. So I want the midpoint between -1, 3 and -3, 1. And I know the formula is on the previous page now, but let's do it. So in order to compute the midpoint, add up the x-coordinates, divide by 2. That'll give you the x-coordinate of the midpoint. So
add up the x coordinates, so -1 plus -3 all over 2, comma, add the y coordinates, 3 plus 1 all over 2, and let's just see what that is. -1 minus 3 is, I guess maybe I can just stall for a moment and you'll tell me what this whole coordinate is. X coordinate is -2. Y coordinate is 2. That agree? Nice. And I am quite pleased that I didn't see anyone reaching for a handheld calculator to make that computation. Nice. -2, 2. Let's see if it's reasonable by just drawing these points. So let's draw on this Cartesian coordinate system the point -1, 3, the point -3, 1, and the point -2, 2. That green point seems like it's about halfway between those 2 points? And it looks a little off, but you can't trust me to draw a picture to scale at any point in this class, so it won't look perfect. Nice. So, I see in looking at the clock that I'm still behind. That's not a terrible surprise. I'll take a look at the schedule later today and decide what revisions I should make to it. Nice. So, things to do between now and tomorrow. Take a look at the homework assigned today, decide if it looks reasonable. If it doesn't, then ask me some questions about it. Take a look at the rest of the notebook, see if there's anything interesting in there that you want to explicitly ask about. Rudy. Oh, and if you wouldn't mind, like, bringing back those tape measures, they were cheap, but I don't want to have to buy any after. Excellent. Thank you. Thank you.
So your pricing things look far.
Pretty good. The next one's got a little concern.
Yeah.
Computer system.
How are you?
So I have to learn software engineering. Yeah. I was doing that.
Oh, yeah, I think you did.
And we go to
Oh, that's good. Or, yeah, no.
versus software engineering.
Yeah, I had that experience.
Stats and
Low and Elmo Gurney. Excellent.
I changed majors from psych to computer science, and then computer science to software.
And you sit in about that spot, right?
Yeah.
Okay, excellent. I'm just also making sure that my seating chart is going.
Okay, sorry.
Thank you.
Okay, let's unpack. Okay, so the homework that you assigned yesterday, correct, is due today, or is due in 5 days, whenever you finished.
The due date should be correct on campus.
Okay, so like 6
Everything's due a week after the day it's received.
Okay, just.
So Monday of next week.
Okay.
Yeah. And if do you find yourself to be someone who consistently stresses about due dates for homeworks?
No, I just want to make sure that I am doing it in the time that the student practice.
Yeah.
Anyway, and then I don't know.
Okay. Yeah, I'll point out that I'm very forgiving about deadlines.
The way that you had our example, it doesn't necessarily how you want us to write our answers, right?
Which example? Oh, like in the campus thing?
Yeah.
Yeah, that's probably more detailed than I would expect. But certainly if you include that much detail, I'll never be mad that you included too much detail.
Okay, and then we submit the.
Yeah, there should be an upload button to submit that. Yeah. ask me some of those questions again at the beginning of this, because I think that would be relevant for all of this.
How do you from this like because when I put on like the I was like looking at like the days like 0 and then 1 I don't know.
This is interesting. Can you put day 1 back on this? It's not a valid set.
I don't know. I was trying to figure out how to ask me how it works, but I can't figure it out.
I'm going to, so this, let me ask everyone a general question to see if this is unique to you or everyone's life. So how many people have looked at the web walk at this point? Did you actually see like homework problems when you clicked on it?
The one for Jay or the one for
I thought.
Yeah.
You did? Okay. Then show me how you clicked to get the web. Yeah, it's better on
Here.
Okay, try clicking, click that one more. This one that says January. Awesome. Okay. Okay, cool. So I think I understand what happened. So this one is actually, so WebWalk makes you an account the first time you click on a thing that's actually a WebWalk. So now go back and try clicking on the thing that says WebWalk access in Canvas now, if you don't know. Back into Canvas, and now go back to home and do the thing that says WebWalk access. And see if that doesn't work, then I just need to go with that. Yeah, okay. I might just have to, and you can't click any of these.
What's up? Yeah, it's weird. Okay, well, I got this.
Yeah. I will move the thing that says WebWalk access, because apparently that's one.
Okay.
All right, so with a few minutes before time, people have any questions they'd like to ask about? Possibly homework related? Possibly logistical questions about something in the Canvas doesn't seem to be walking?